Welcome to the 2020 Summit on What Next for Wireless Infrastructure, hosted by the University of Surrey 5G Innovation Centre in association with TelecomTV and supported by ETSI. I'm Guy Daniels and I'm your online MC and session moderator for this two-day event. Now we have two further sessions of presentations for you today, followed by a live Q&A panel discussion, and we really want to hear from you. So please submit your questions for our guests. There's a form here on the website for you to use. I'm joined once again by our host, Professor Rahim Tafazoli, who is head of the ICS and 5G IC at the University of Surrey, and by our chair for day two, Dr. Mike Short, Chief Scientific Advisor for the UK Government's Department of International Trade. Rahim, yesterday's sessions focused on the 5G promise for the coming 5 years or so, but today we're looking a little bit further ahead into the next decade and, dare we say, 6G. But with 5G only just rolling out at scale, what do we gain by looking at future wireless infrastructure technologies now?
Well, thank you, Guy. This was important to everybody to understand 5G capabilities, what has already been standardized and what are going to be standardized in future releases, and what application, well, in fantastic set of application will be enabled with 5G. Having that understanding, we can think about what should be the future research and challenges, which is beyond 5G capability. And that is what we plan to establish. We have European Commission talking about 6G strategy for Europe. And we have major industry players from all over the world, which I consider them as the major influencers, hopefully present their 6G perspective and vision for 2030 plus. I also will present 5G IC vision, which we have compiled and discussed it over the last 9 months to 1 year, and say what would be the research challenges for 2030 plus. And we will launch our white paper vision document. And I will also have a nice surprise for everybody to demonstrate one technology, 6G technology. I will not talk about it more. I'll leave that surprise to the later time in the day. But officially, I would like to establish a common vision internationally towards what are research and innovation challenges for 2030 plus, which we could eventually call it 6G.
Thank you, Rahim. And I certainly can't wait to find out what you've got in store for us, what this big surprise and reveal is. Very exciting. Mike, as chair of day two, what can we expect to hear? Rahim's covered a few things already, but what else are we looking at today?
I think we're going to cover a lot of ground, which is complementary to day one. We've got 10 very exciting speakers, as Rahim has referred to, but I think we'll get a better flavor for some of the priorities when it comes to not just research, but also investment. And I think one of the key areas for thinking about the longer term is we have to prioritize both the research and the investment. So starting off, we'll have the European Commission, Bahrani, who is Deputy Head of Unit in DG Connect. But we've also got 2 major operator speakers and 4 leading vendor specialists, and indeed some contributions further from the academic community later on during the day. When we put it all together, I think it'll guide people to think about the longer term and to think about what sort of support is going to be needed in this area between vendors and operators and other members of the ecosystem, including the research community. Unless we collaborate now, we could get it badly wrong. We've seen from previous generations the benefits of collaboration. We need to collaborate in a better way going forward.
Thank you, Mike. Raheem, we're halfway through the event, but it already feels like there is even more focus from researchers, from industry and from policymakers on the next generation of wireless and what's to come than we've seen with previous generations. Will this level of security make it even more challenging to agree on global standardized solutions?
Well, I think it is very important to have a global consensus, first of all, on the direction of the research and innovation challenges in order to maximize the academic and industry effort in the same direction, and we innovate for 2030 plus. I appreciate the security concerns, but that doesn't mean that we should have regional standards. One of the important aspects of the telecommunication and over many generations is the technology we develop is a global standard. From the economic point of view, that facilitates faster return on the investment. It would facilitate roaming between different countries, between different regions. And at the end of the day, the global standards would benefit the users in terms of the cost, in terms of the technology advancement, which we could would be combination of different technologies from different part of the world and academia and industry. But we need to allow new players to get involved in the ecosystem for diversification of the vendors, and we should not, and that should not compromise a global standard. We should facilitate the new players to get involved, small and large companies from different regions, and offer their products and their solution.
Mike, you've been so closely involved with the development of wireless cellular. Are the stakes higher now than in previous decades as the digital economy plays an even more crucial role in our lives?
I don't think the stakes are higher. I think the opportunities are higher. But I think we need to think about this differently from previous generations. Clearly, previous generations have been used to thinking about optimizing spectrum and thinking about single networks. We're moving into a much more combinational network world where it's no longer just cellular, but it could also be fixed wireless access as well as Wi-Fi. It could also be satellite, as we've seen from some of the talks yesterday. We can also see the need to combine network elements across different radio access areas and wireline access areas. So maybe looking more beyond the common core to common services that transfer across networks. I also think, going back to your previous point on security, we need to be looking at end-to-end security across networks, not just for single networks. And therefore, that means how do we bring in the opportunities with many new players in the softwareization space, the cloudification space, if you like. How do we bring them in to help bring about higher levels of security end-to-end across all these networks? Now, on a longer-term basis, this is hard when we've grown up with specialist network designs, and looking at combinations is tough. But we need to do more in that area to add more capacity and capability to the communications that we will need. These are some of the natural challenges that the researchers need to help us with in collaboration with vendor communities as well as operators.
Thank you, Mike. And we'll be speaking again later in the day during the live Q&A session. A reminder that we want to hear from you, so please use the website submission form to send in your questions. The session will start at 4 p.m. UK time today. Mike, could you please do the honours and introduce our first presentation for this final day?
It's my great pleasure to introduce a representative from the European Commission who've been very helpful since the early days of mobile and GSM in all their support. This is Bernard Bahrani, who is the Deputy Head of Unit in DG Connect within the European Commission. And if I may say so, the floor is yours.
So good morning or good afternoon for this virtual talk. My name is Bahrani. I work for the European Commission and I'm Deputy Head of Unit of the division called Future Connectivity Systems in DG Connect. And this is the division where we have basically two main roles or two main competencies. Is about research and innovation. That means it's our responsibility to put in place a strategy and implementation for research and innovation in the field of networks, telecoms, and related IT systems. And the second of our activities is about helping Europe to put in place the framework conditions for network deployments. That means these days 5G deployment. That means helping member states to have a coordinated approach towards 5G deployment. So at this moment in time, as I said that we have a research and innovation role, we are in the process of defining our future programs of research in telecom. And of course, 6G comes as, let's say, the elephant in the room. And that's really our priority now to check what we are going to do in the next phase, next years in this particular topic. But before we do that, a few words to tell you exactly the framework under which we operate at this moment in time. As you probably know, the new commission led by President von der Leyen has published its political agenda beginning of this year. And you can see, this is on the top right-hand side of this slide, that under this political agenda, there are 6 priorities, one of them being related to digital. So digital features prominently in this political agenda. From several perspectives, digital as a technology being used and serving digitization of the industry and the society, but also European actors and European supply side being much more able than today, possibly, to supply the right technologies to the market, which is sometimes dominated by non-European players. So in that context, the notion of open strategic autonomy has come at the forefront, and this is something we are discussing now with the member states, how we can move forward with Europe towards more prominence on the supply side of digital technologies. In this political agenda, there are also other issues that we believe are very, very important, very relevant for digital. That means the so-called Green Deal, which is our commitment to tackle climate change. And this is a domain where we believe digital technologies have a lot to offer. And also economic impact and better economy functioning for the citizen. This is again a domain where I believe digital has a lot to offer. So in that overall context, political context, 6G has been identified as one of the prominent technologies that can contribute to this political agenda. Our commissioner, Thierry Breton, has made a couple of public interventions where he said that we have to move now or to make it such that Europe gets prepared for the next wave of network innovation and 6G. And in that context, we published, beginning of January this year, 29th of January to be precise, a communication on a cyber security toolbox in which we announce specifically, explicitly, our intention to set up a partnership with the industry, with the private side, so industry and research actors, to develop a European approach towards 6G. So, of course, this roadmap has to take into account what we see developing all over the place and globally. We have seen a lot of announcements on 6G lately in the next couple of months. I think the most recent one being the one of Korea in September that announced under the Ministry MSIT the launch of a Korean 6G initiative with some amounts of about 200 million euros, I think they mentioned. Japan also published a roadmap in June this year. China already started next year setting up a working group on 6G. In Europe, very interesting, one initiative was already started last year in Finland. It's the so-called 6G flagship led by University of Oulu, which is funded, I think, by the Finnish actors up to a level of 250 million euros for 6 years. So it's already an important initiative, which we expect will, of course, be a great contributor to the European roadmap for 6G. So in that context, what did we do? We started already to think about what might come after 5G, or what might come as complement to 5G. And already 2 years ago, we started to think a little bit of what we have to focus on. And one thing that came prominently, and I think this is the kind of things you find more or less in all the global roadmaps, is the intention to concentrate more on non-functional properties such as security, energy consumptions, or societal issues, which are not things which are directly visible from the point of view of the application that serves the users, but which are very important to make the technology sustainable. One element being, for instance, EMF and electromagnetic radiation. We see that today 5G is being deployed in Europe. We have about, I think, today 30 networks in 15 member states, which are active networks today. But we see something we did not expect at all, which is a lot of resistance to 5G deployment, with a lot of activists propagating all sorts of news, fake news, on the performance of the impact of 5G on health, human health, or animal health, or whatever. So these are important aspects to take into account for the future, but also the aspects which are related to, as I said, sustainability, energy consumption. Energy consumption is related to climate change, but it's a political priority, but it's also important from an economic perspective, because the energy bill of the operators is quite high. So there is the intention to minimize this type of costs. And also other aspects such as coverage. We today have 3.5 billion people all over the planet which do not have any internet connection or internet access. Issues such as trust, data control by users, security are also coming very strongly as important drivers for future research on 6G and on future networks. Not that it's not there in 5G, there is already a dimension of 5G that addresses all these concerns, but we would like to see if we can push that a little bit further. So from that perspective, we start to develop now, from the functional properties side, a vision with the stakeholders and with industry, where we see basically two aspects. One aspect is the continuation of what has been started with 5G. That means the coming together of the digital world with the physical world, which is already well ahead with IoT deployment or massive machine communication type characteristics that you find in 5G. But this is something that will be pushed beyond the limits that we can see today with 5G. And the other element that we see coming, which is potentially new compared to the 5G reflection, when ITU published its vision in, I think it was in 2013, something like that. That's the coming together of the digital world with the human world, be it from the perspective of the biological characteristics from your skin, from your body, or from the perspective of the behavior of the persons and how the networks can be used to collect this information and to transmit this information towards the benefits of applications and towards the benefits of users, of course. So from that perspective, we have identified at this moment in time 6 dimensions of 6G. These are not the only ones, but let's say these are the core ones. So from the application side that you see at the top of this chart, on the right-hand side, you can see a number of developments that we expect that will push the envelope of the performance indicators that we have now in 5G. That means moving beyond the 5.9 reliability objective of 5G. We hear from some industrial environments that they would like to have 7.9 reliability figures instead of 5.9. Maybe we need to move below the 1 millisecond latency that 5G has been promoting again in very specific harsh industrial environments. gigabit per second towards terabit per second. There are also some applications that probably will go in that direction. So this is really stretching the envelope of the performance indicators of 5G. On the left-hand side, on the application, we see another dimension, which is more new type of applications, such as what I mentioned before, the Internet of Sense, the coming together of sensing and communication, which is a promise of terahertz communication. I think all the people working on 6G today work on terahertz communication at the same time, but also other type of applications, such as holographic communication, that require potentially massive data rates, and which has potentially an impact on the network architectures and how the data streams are served from a local perspective. At the bottom of this diagram, you can see what I mentioned before as the societal focus. On the left-hand side, the aspects which are related to energy consumptions both from the network platform perspective, so trying to bring the network consumption as low as possible. And here we believe that the new reflection has to be started, because the more we go towards densification, the more we go towards processing at the edge, the more we have a kind of trade-off to achieve between the consumption that comes from the processing and the consumption that comes from the transmission. Today, most of the consumption comes from transmission, but in the future probably will not be the case. So there will be some trade-offs here. And also energy consumption from the point of view of how to serve the vertical users to optimize their process through these network platforms, and optimizing their process in the context of also optimizing their carbon footprint. So that's one thing. The second societal element is what we mentioned as accessibility of the technology, or affordability of the technology, which will be pushed forward by new approaches like Open RAN and massive softwareization and disaggregation of networks, which potentially will bring the cost of the technology much lower, and which again opens some prospects for more massive deployment of this new generation of networks. And in the middle, of course, all the aspects which are related to network management, the so-called FCAPS characteristics in the telecom jargon, trying to move towards fully automated networks. Here, artificial intelligence plays a major role, but also other technologies from the security side, be it blockchain or quantum, are technologies that are potentially called upon to being integrated into these new platforms to serve a more strict type of requirements. So from that perspective, we have developed what we call smart network and service partnership approach. And this partnership approach is based on what we call a value chain. So far, when we started the 5G public-private partnership in 2013 with the European actors to support, again, European research in 5G, we were coming primarily from the telecom world, and our objective was really the network platform, because this is one of the strong assets of Europe in digital. Now our approach is to try to be a little bit more holistic. That means to leverage European assets in telecoms to try to also address devices from the IoT perspective. If we assume that there will be billions or zillions, I don't know what are the projections, but a huge amount of connected devices, that will open opportunities for new classes of devices beyond smartphones. And also from the perspective of edge cloud, having service platforms at the edge is something that we want to integrate into this overall roadmap and reflection to develop a complete value chain with presence of European actors, including, and this is maybe new compared to the approach we took before, at the level of enabling technologies and components. For instance, if we have to go into terahertz frequencies, I believe we have to start from the onset, to start with the microelectronics industry to identify what kind of roadmap they can put forward to have a European approach towards this type of components, including at processor level, which is here maybe a more difficult reflection because Europe has no real capability in processors at this moment in time. So these are developing topics, but we intend to look into those a bit more systematically. So from that perspective, where are we now? We are coming to the end of the current program, which is called Horizon 2020. So the legal base of Horizon 2020 terminates this year. And under this Horizon 2020, we have implemented the 5G public-private partnership that I mentioned from 2013 to 2020. So this is coming to an end, which is normal, as 5G is not anymore really in the research domain. But we are now launching 9 projects that will be active at the beginning of next year, precisely to work on 6G roadmap and on 6G dedicated technology. So we have one so-called flagship project, which is led by, let's say, the classical actors of the European telecom ecosystems, both from the vendor side and from the operator side. And then we have a number of 8 satellite projects which are dealing with specific technological aspects. These 2 years projects will be active as a kind of bridging phase into the partnership, the smart network and service partnership that we intend to launch between mid and end of next year, for which we propose a budget envelope in the order of 1 billion euro for 7 years. So at the bottom of this slide, what you can see is the so-called industry proposal for the smart network and service partnership that we received a couple of months ago. So you can find and download this roadmap at the URL that you can see on this slide. This is the kind of work program that industrial actors are proposing to us to back for the implementation of 6G initiative in Europe. And as you can see, this initiative is supported by 5 industry associations, 5GIA, which is the 5G Infrastructure Association, which was our main partner, which was our partner for the 5G public-private partnership implementation that we started again, as I said before. But now they are being complemented with other associations which are representing more the cloud and IoT domains, because as I said, in the context of this value chain, we want to have also these aspects more prominently addressed in the 6G initiative. And this initiative will have 2 legs. One leg which is on deployment. Primarily, this is a short-term type of activity, which is promoting deployment of 5G for dedicated applications, for instance, the automotive sector or in the factory sector. So that's the deployment side. And on the research side, on the right-hand side, the green box, we will work on the technologies to achieve the 6G vision that we are in the process of putting forward. So at this moment in time, this is our roadmap, and again, we intend to launch this partnership next year. If you are more interested, there will be also an event with ETSI, 24 and 25th of November, that you can reach at the URL which is indicated on this slide. At this event, we will explain a little bit more the various aspects of what we intend to support. And also there will be an element of reflection at this event on how can we promote the spin-off of research results into standardization domain. So that will be the main aspect of this workshop. So with this, I want to conclude my presentation by thanking you very much. And again, you have my email address on the first slide of this presentation. So in case you would have any clarification question, don't hesitate to contact me, and I will do all my best to try to answer you. Thank you very much for your attention.
You're watching the 2020 Summit on What Next for Wireless Infrastructure. Coming next, we have a presentation from Tong Wen, CTO of Wireless at Huawei and an IEEE Fellow, who will give a perspective on 6G.
Hello everyone. First of all, I would like to thank Rahim and 5GIC to organize this Digit Summit. Thank you for the invitation. In this talk, I would like to share our view on the research and the innovation challenges beyond 5G. Since 6G is 10 years ahead, we look at this topic from the angle of big drivers and emerging technologies. At high level, in addition to wireless technology innovation, overall, there are several key factors that will impact and shape 6G wireless network architecture. Number one, the primary motivation for 6G network architecture evolution is AI. In 6G, AI will be the dominant services and applications. Number two, because the primary new spectrum for 6G will be the millimeter wave and even terahertz, we have an excellent opportunity to apply wireless sensing capabilities. In this case, the entire wireless network is a sensor network. The wireless network and the device can do real-time sensing. Number three, 6G will be effectively become the fabric to link between the physical world and the cyber world. From this perspective, the key features of radio network access are shown in this chart. First of all, from the cyber world to the physical world, this is a typical downlink. The primary service will be the virtual reality for everything, and to access any digital copy in the cyber world. And then we have the wideband tactile channel as the augmented neural system for the physical world. And then the inference channel to exchange the trained AI engine with the end user. Second is from the physical world to the cyber world. This is a typical uplink. The primary application is sensing and to collect the big data for the machine learning. Now, how to compress the huge amount of big data to the network for the machine learning? This is a new challenge. We are working on to apply the information bottleneck theory to explore the new compression technology to train the deep neural network. On the network side, we have 6G base station node and 6G edge node. For the base station, we will have both sensing capability and to sense the environment in real time, and for the machine learning capability. The edge node will mostly use for machine learning as well. In this sense, the classical data center at edge node become the neural center. The base station become the neural node. For the fiber optics link between the neural center and the neural node, the quantum key distribution technology can be deployed. The last new element in 6G is massive low Earth orbit satellite constellation. This is for build up the integrated non-terrestrial and terrestrial 6G network for the ultimate full Earth coverage. In a nutshell, 6G is transforming from connected of everything to connected intelligence. To further boil down, 6G is to use mobile technology to deliver artificial intelligence to everyone, anywhere, at any time. We can leverage 6G wireless network as a sensor network and to perform network-wide machine learning. However, in an AR-centric 6G network architecture, with the convergence of communication and computing, the biggest challenge is the computation model. In the recent study showed that in the deep learning computing era, the computational complexity is at the range of a polynomial growth of order 3 to 15. To train a model with less than 5% error rate, we need $10 billion of computing cost for 10 billions of gigaflops of instruction. The optimized core design with the algorithm for the neural center should be provisioned. In this sense, the AI GPU will eventually replace the CPU, and the new type of virtualized network function will emerge. It is expected that the policy-driven reinforced learning can make the network operational and management fully automated. In his joint work with Shannon in 1949, Warren Weaver categorized 3 levels of communication models. The first is the technical model, which is the Shannon information theory as we know today. The second is a semantic level. The third is effectiveness level. For machine learning point of view, we can study the 6G new communication model with 2 concatenated channels, the inner channel and the outer semantic channel. A lot of machine learning communication, for example, machine-to-machine communication, human-to-machine communication, and machine-to-human communication can be made more efficient. Since fundamentally communication of intelligence is a learning as well, with this new model, we can truly customize and learn deliver many personalized service. The network and the computing architecture of 6G will require more research, especially the distributed machine learning. How to split computing and the AI model at the different part across the network. How to architect the neural center with pools of computing resources, and how to orchestrate these new neural resources. 6G architecture will consider data governance and trustfulness. In particular, we see a regulatory rules for data protection and privacy protection. These will apply the networking. For the future of AI, service and applications, this will become an essential capability for 6G. Another challenge for 6G is the many new network elements. Some of them belong to the fixed infrastructure, for example, the edge neuron center, the base station, sub-6 GHz massive MIMO, millimeter wave radio, and the satellite constellation. There are many more mobile devices than previous generation wireless, such as wearables, sensors, drones, cars, robots. And there are new temporary infrastructure with mobility such as a car, train, drone, and hubs. Fully integration of these network elements will be considered for 6G architecture design. At this point, a unified global standards is even more critical for 6G in order to achieve the business success and the societal impact at unprecedented scale. For the very low Earth orbit satellite constellation, in addition to full Earth coverage, VLEO constellation can provide a global low latency service to anywhere in the Earth. For example, in this diagram, with the SpaceX constellation, the VLEO latency can be lower even than the fiber link. In this case, New York to Los Angeles, New York to London, New York to Shanghai, Shanghai to London. Another aspect is the application with video satellite for bandpipe transparent forwarding. Within, say, 500 kilometer radius, we can compute the URLC service at edge computing center and use bandpipe to control the autonomous driving. These are the two disruptive new services that 6G can offer. Finally, we can summarize the 5 drivers for 6G network architecture. The first driver, from cloud-centric to AI native. This is because the composition of a 6G network will consist of AI models and AI computing. The network operation will be AI capable and truly zero touch. The second driver, from information-centric to network as a sensor. This is because the network-wide sensing and the device-assisted sensing will make radio access network with additional side information. And the real surrounding environment sensing is a new type of real-time 4D digital map, which in turn can support all the AI application. And this is a big value-added service to any applications. The third driver, from security-centric to multilateral trust model. This is because in addition to secure the information pipe, we need the network platform to build a network platform for many new business and players. The trust and the privacy mechanics will be incorporated in the 6G architecture. The fourth driver, from the generic pipe to user-centric model. This is because every user, every service are composed with a customized and optimized network, as if the network is mine. The fifth driver is a new business model, from optical-centric to the prosumer-centric. This is because the operator-owned public network can be extended and augmented with the other players and actors to provide new infrastructure and to build new services. As we can see, there are many interesting challenges and opportunities for 6G research. I would like to take this occasion of the Digit Summit to look for collaboration with the academia and the industrial friends. And with that, I conclude my talk. Thank you very much.
A reminder that we have a live Q&A session at the end of today, so please send in your questions as soon as you can. Our next presentation is from Paul Crane, Head of Applied R&D with BT. And Paul asks the question, do we need another G? Let's find out.
Hi, my name is Paul Crane. I'm Networks Research Director at BT. I work in our Applied Research Department, which is based out of Industrial Park, just outside London. BT is very proud to be a research active organisation based here in the UK. I've been involved in 5G since the early days of research, through to assisting our mobile division, EE, roll out the first 5G network in the UK. And I think my experience over this time has led me to the conclusion that we probably need a different approach to technology development, whereas we move forward from 5G to future mobile technologies. If you just look at the development of mobile over the years, and we'll all be familiar with this transition from analog to digital, and then voice and text through to mobile internet, through to mobile broadband with 4G, and then the ambitions with 5G of extending that mobile broadband to support ultra reliable, low latency comms and IoT. But since the conception of 5G and early research work, there have been some fairly fundamental changes in technology, in the way we're going about implementing networks, which I think leads us to led me to the conclusion that we need to seriously think about what we do with technology and how we implement technology going forward. The one really big success, I think, over the last few years, since 2010, is the emergence of global mobile standards. So 4G, LTE, and 5G are global standards, rather than before that were regional. And that's been a major success for the industry, and something that we need to really hold on to. What we have been doing is a kind of this generational change approach. So 3G to 4G, 4G to 5G, which has resulted in operators needing to do a major capital investment from one technology to another, and also refarm spectrum from one technology to another. And I think one of the issues we have with 5G is that technology is maybe running a bit ahead of the use cases that were anticipated, and therefore that makes that additional cost and the business case associated with that additional cost quite hard. Now, 5G is being launched in the UK, and so we're very proud to have been the first company in the UK to have launched 5G. And our view is that it's going to be around with us for at least 10 years and probably 20 years, which means over the course of that time frame, we're going to need to support both legacy networks and 5G networks. So, at least 2G, 4G and 5G, possibly 3G as well, over the next coming years. And again, that results in a major OpEx cost to companies, operators, in having to do that. That's another drag on the economics of the company, and therefore that's something else we need to consider when looking at future technologies for mobile networks. Now, since the advent of 4G, and particularly over the standardization period of 5G, there has also been another fundamental change going on, and that's the way we go about building networks. And it's probably the most fundamental change in the way we build networks that I've seen since being engaged in the industry. And that's based on virtualization, based on disaggregation of network functions, and based on the advent of open architectures. And what this will result in is us having a very flexible, a very agile infrastructure. And it seems strange that we would then take a backward step of putting an agile infrastructure in, and then having to go through a generational change from one technology to another. So I think that's one aspect that we need to seriously think about. Now, I think the 5G technology has been really running ahead of the development of use cases beyond mobile broadband. Now, it's going to be another 2 to 4 years before we get the features in 5G which supports ultra reliable low latency comms and supports mass deployment of IoT machine type applications. And so I think it's up to us to be working with industry to work out, what those use cases, practical use cases will be. But then projecting forward, beyond those use cases towards, say, 2030, when we may be thinking about, a new generation of technology. I think it's really hard for us network engineers to come up with those use cases. And I think it's absolutely vital that we work with industry, businesses, to really understand what they think they're going to need in that time frame. And therefore, I think it is way too early for us to be thinking about setting, performance characteristics and parameters for something beyond 5G. And it's way too early for us to be calling out use cases as being 6G use cases. I think we can say they're candidate parameters, and I think we can say that they are candidate use cases. But it's way too early, I think, than to be specific. We, however, can, I think, set a general direction. And some of the things on this slide, I think, are things that we would pass the red face test in saying, yes, managing world's resources is going to be important. Opening up the digital world to everyone is going to be important. Always being connected is going to be important. So I think those general things, I think we can set the context in general direction. We can make some assertions about technologies as well, but I think we can't be specific about technologies. At this stage, we cannot be saying that a technology is a 6G technology. It is a candidate technology that could be implemented in 6G. Things we can say, though, wireless connectivity will be increasingly essential to the digital economy. We can say that reliability, latency, and coverage will be equally important as peak rates and capacity. Particularly coverage, and one of the things I was always surprised about within 5G is how coverage really wasn't seen as one of the key parameters for the service. And I think that is something that we need to really focus on as a technical community, economic coverage. Now, if the use cases that we've been talking about, mission critical use cases, do come to pass on wireless networks, then you can guarantee that those networks will become another attack vector. And therefore security, both cyber security and security against DDoS or protocol attacks, is actually going to be vitally important. So security and trust is I think we can assert something that needs technical focus on. Sustainability, particularly energy usage, will be key. And from the fundamental silicon through to the end-to-end system, how to reduce energy out of the network. Now, there's no sign that the current economic trajectory in telecoms is going to change, and by that I mean usage and bandwidth usage going up, but with no associated revenue associated with that increased data usage, which results in us having to put more and more equipment in the network, spend more and more capex, but effectively for no increased revenue. And therefore, we need to continue to drive down on costs. We can also say, I think, with certainty that new equipment supply chain players will emerge based on that virtualization and open architectures. That will drive innovation in the supply chain, and will be a benefit to large operators, large vendors, as well as potential new players in the market. And finally, one thing I think we can reasonably assert is that network usage patterns will change over the next 10 years. There will be many more machines connected than people. And if that's the case, then usage patterns will potentially change as well. And again, that's maybe a key requirement for the way networks are built in the future. So what do we need the technical community to focus on? Well, capacity, the traditional telecoms engineer of farther, faster, cheaper. I think that will continue. One thing we need to think about seriously in that, though, is the element of cost. Mobile operators try and avoid building small cells as much as they can because of the costs associated with small cells. And therefore, you'll see, how on the early days of 5G, millimeter wave was, seen as a great opportunity for increased capacity. But in most geographies, the use of millimeter wave is still a long way off, and that's primarily because of the costs associated with deployment. Now, I don't see that changing. So, for example, I wouldn't call terahertz a 6G technology. I would call it a candidate technology until it's shown what use cases at the appropriate costs it can actually work in. I've mentioned coverage, so just picking out one or two others. One of the key things for an operator is a smooth investment profile. And those generational changes that we've been talking about previously do not enable that smooth investment profile. And therefore, for future mobile technologies, I think we need to look at how we move away from these generational changes to much more of a release-based approach where an operator can put functions and features in the network that much more match the market demand. The 5G journey has only really just started, and it will be with us for 20 years, at least 10 to 20 years. I think it's just way too early to be firmly identifying 6G use cases, 6G parameters, and 6G technologies. I think it's the right time for direction setting. It's the right time for looking at candidate technologies, candidate use cases. But we cannot say a particular technology is a 6G technology. I think we need to take a multidisciplinary approach here, bringing together the engineering, social sciences, material science, and industries to work together to define what is going to be required of a wireless infrastructure in that 2030 timescales. Now, the way that we're implementing networks is to drive flexibility, is to drive innovation into the infrastructure. And so it would seem odd to constrain that with another non-backwardly compatible technology, another G. And therefore, I think we need to think about a different approach that takes into the constraints that the industry is going to be on in that 2030 timescales. And finally, global standards are essential. And we should keep mindful of that the big success of 4G and what will be the big success of 5G is based on global standards. And we all need to make sure that as a regime continues into the future.
For our next session this afternoon, we are joined by David Lister, Senior R&D Manager Futurist with Vodafone Group, whose presentation considers perspectives beyond 5G.
Hello, I'm David Lister. I'm one of the research managers at Vodafone Group Research and Development, and today I'll be offering my perspectives on beyond 5G. So this is an exciting industry, it always has been. It's characterised by continuous innovation and delivering services that are an essential part of everybody's lives. And in the few minutes that follow, I want to give a recap of where we are today, firstly on our broadband services. I'm going to reflect some of the key technology changes that have already happened, because I think we can learn from that and how that will influence the future. And then I'll be going on to talk about my perspectives of beyond 5G towards 2030 and beyond. So if we just start, first of all, of recapping where we are today. Mobile broadband growth, which is these bars on this chart, has been growing by an incredible factor of 7 in the last 5 years. That's a cumulative growth of about 30 to 40% year on year. And whilst that data growth has been increasing, the price that the customer pays has come down by about 85%. So the price that the customer pays per gigabyte is 85% lower in that 5-year period. Now, this has all been enabled because 4G has been a hugely successful technology. It's delivered economies of scale, it's been deployed internationally, it delivers great customer experience. And against this backdrop of continuing demand on capacity and continuing demand on growth, we have to look forward to 5G and beyond to work out how we can best deliver, make sure that the industry is sustainable, both environmentally and indeed commercially. Now, as well as the capability that we're offering through the 4G service, we've deployed it nationwide. And to date, 97% of houses now have 4G broadband from all operators. And indeed, almost all houses, and over 90% of the area is covered by at least one operator. So this gives a fantastic high-quality connectivity layer, and it forms the foundation for which 5G will be built upon. 5G will extend the performance. It will increase capacity, particularly in urban areas, and it supports new services. So I'd like to start with reflecting on some key technology steps and generations in the past. And before I start, I wanted to quote this old Danish proverb: making predictions is difficult, especially about the future. And it's particularly relevant, I think, in our industry, where we're trying to forecast 10, 15 years ahead. And I'd like to reflect on the iPhone, because the iPhone was such a transformational device, and it transformed not just people's interactions with their devices, but the whole industry for years to come. And on the left, we had Steve Jobs there, and he recognized there was an immediate need to improve the user interface with smartphones. Existing smartphone devices had fixed keypads, fixed buttons, very inflexible, and a very poor use of space on the handset. So he identified this new clear customer need, consumer need for a new device. When the iPhone was first launched in 2007, it really was quite revolutionary. But even when presented with that future, his counterpart, Steve Ballmer, who was the CEO of Microsoft, he said there's no chance that the iPhone is going to get any significant market share. No chance. And it took many years for him to change his mind and admit that was a mistake. So I think it's just useful just to think about how difficult it is sometimes to get the future even remotely correct. Steve Jobs definitely managed it. And he went on to say, the iPhone is a revolutionary product, 5 years ahead of any other mobile phone. And what he was very clever at doing is spotting that is the user interface. We're all born with the ultimate pointing device of fingers. And the iPhone uses them to create the most revolutionary user interface since the mouse. And with that new user interface, Apple were able to sell its main features, its widescreen iPod for music. They described the device as being a revolutionary mobile phone and a breakthrough internet communication device. So all about revolution and big changes on the iPhone. Now, as a technologist, looking at the technology components that were introduced, well, maybe it wasn't quite so revolutionary. 4 of the big features that were advertised was its touchscreen user interface, advanced sensors, edge GSM connectivity, and a 2-megapixel camera. Now, certainly the sensors and the connectivity and the camera, they were very good, but they weren't particularly groundbreaking at the time. The thing that really made the difference was the touchscreen interface. And in fact, the touchscreen interface had been patented in 1989, and there's 20 or 30 years of development before the iPhone was launched that enables the technology to be matured. And in many ways, and certainly in my view, the key thing actually what the iPhone did was it provided a new operating system, a new software platform. And that operating system, software platform, enabled all the innovation, all the apps and all the widgets and all the new services that other people innovated on and made available to the customer. So very largely, in my view, it's to do with software, and it's to do with building on the technology components that indeed other people have already identified. So taking that sort of learning through and just thinking about it from a network perspective, and this is so we can work out where do we go beyond 5G. Again, if we look at how networks have evolved, the transition to 3G to wideband code division multiple access, or wideband CDMA, was very much based on the learnings that we had from CDMA IS-95, a technology that was deployed mainly in the US markets in the 1990s. When 4G came along and we introduced orthogonal frequency division multiple access, or OFDM, that was very much based on learnings that have been demonstrated and proven through WiMAX, Flash OFDM, and DAB broadcasting. And 4G in itself very much forms the foundation for 5G New Radio, which is also built on the same radio physical access layer, OFDM. So there's a clear learning from previous technologies that influence the future. And I think it's equally true, looking beyond 5G, that will be influenced by today's emerging technologies. So to a large degree, wherever we go in the future, we can look around us and say, well, what technologies are starting to emerge today, and how will they form that future and help to create that future? And one of the things I think it's worth noting just before we leave the generational story is that there is no clear radio access layer alternative to OFDM at this current time. I think that's quite important because that suggests that actually the connectivity layer, the radio access layer, may be coming to a level of maturity that the previous generations didn't actually have. So when a new generation is discussed, quite often it's the ITU, the International Telecommunications Union, that sets the requirements for that next generation of technology. This was the case for 4G with IMT Advanced, and it was the case for 5G, called IMT 2020. And the ITU set very ambitious targets and ambitious requirements. For example, they set a requirement of 20 gigabit per second on the downlink, a spectrum efficiency 3 times better than what the previous generation was, and a latency of 1 millisecond. And these were very ambitious targets, and it set the targets for the 3GPP standards organization to then develop a technology that meets these requirements. And in theory, 5G NR fulfills all these requirements. But in practice, to achieve some of these data rates, for example, 20 gigabits per second, that requires 640 megahertz of downlink spectrum. That's more downlink spectrum than all the mobile operators in a given market has for 2G, 3G, 4G, and 5G. And whilst there will be more bandwidth available in higher frequency bands, those higher frequency bands aren't appropriate for nationwide wide area coverage due to propagation limitations. So real world limitations will come into play and restrict the ability to reach some of these most demanding requirements. And those limitations are not just spectrum, but it's radiated power, it's site density, information theory, non-ideal radio conditions, and commercial reality and economics. So with that background, what do we really want a future technology then to address? Well, these are global technologies with economies of scale for billions of people, so they need to address global challenges. And the UN Sustainable Development Goals is a good starting point. They identify, for example, equality, prosperity for all. Very mindful of the climate challenge, the carbon and climate challenge that faces us all. So our networks and the way we operate them have to be managed in a carbon-friendly manner, and the services that we introduce have to be able to help other people reduce their carbon footprint. We must make sure that the service is cost efficient for both delivering ubiquity of coverage and has a route towards a capacity growth that matches that type of demand that we saw earlier on in the presentation. As we saw with the iPhone, if we can introduce innovative services, if we can introduce a platform that enables other people to introduce innovation, that leads to good customer outcomes, introduces competition, introduces more choice, introduces more innovation, and that gives more likelihood of more features, more services, more advances in both the handset and the network. We should always focus on the prioritization. The customer comes first, whether that customer is a machine or a person. It's reflecting what a customer need is that will lead to a solution that's ultimately going to be successful. So if I can suggest some pointers towards the future, and bearing in mind the caveats at the beginning, it's very difficult to predict 10 or 15 years into the future. But firstly, I think we need to avoid arbitrary technical targets. We put the customer first. We also need to recognize that the spectrum resource is limited. So further changes to the radio access will have diminishing returns. We probably have to build on the spectrum broadly that we have today with some extensions. The emerging technologies of today, I think, will shape the future in 2030. So millimeter wave bands and massive MIMO, they're starting to be deployed in some markets around the world, but it's still a relatively immature technology. I think we'll see much more of this in the future as the technology matures. We'll see new applications and use cases using those frequency bands. There's much higher frequency bands called terahertz, which broadly are around 100 gigahertz or maybe higher. The thing which appears to be quite exciting about those is that it offers the opportunity for joint sensing and communications, the ability to sense the surrounding environment and to communicate, probably to objects in close vicinity, to offer new features on the handset. And reflecting the limitations on the availability of spectrum, I think we're going to see a much more creative use of spectrum sharing with licensed and unlicensed spectrum to enable capacity growth to continue to increase in urban environments. But maybe what will dominate everything will be software features, particularly the world of IT and the world of software, building on the capabilities that we're seeing through machine learning and artificial intelligence. I expect that will form a much more fundamental part of not just how operators run their networks, but also in the types of services that people will come to expect and to be able to use. And aspects that support these capabilities will be built into the network natively. And I think it's reasonable that networks will continue to build upon the concept of network slicing and personalization and edge computing. So taken together, I think these final aspects are much more likely to dominate where a future beyond 5G will actually go. Less to do with hardware and generations of radio access technology, much more dynamic, much more flexible, much more related to software and IT. Now, the 5G IC Advisory Board have produced a vision paper, which I'm very excited about. They set a vision, they set a challenge to imagine the extension of human sensors and ambient data. And this reflects actually very well on some of the technologies we mentioned previously, the ability to provide new sensing capability at the handset to sense the environment. And they suggest that you can imagine you could extend the communication with the perception of being in the same room from where you are to your colleague. You'll be able to speak to others in your own language via the use of real-time translation technologies. And this might be made possible through edge computing type of capabilities that reduce the latency in any delay. And they suggest that you can interact seamlessly with machines and other health and well-being programs, and broadly to extend the human experience via digital to new sensory perceptions. I think there's quite a creative, quite an ambitious vision that they set out, and it's one I think we can be quite excited about. So if I'd like to just try to wrap up, I would suggest that 6G will drive a different approach to what we've had in previous generations of technology. It's less likely to be associated with radio and radio hardware than what the previous generations were. And I think it's more likely to build on the technologies and capabilities that exist today. And I think it's the services, the software and the IT that will change. And that may well change the network and the services as profoundly as the operating system for the iPhone and Android have changed the handset. So I like to think the future is exciting, and I hope you can join me. Thank you.
For our final session this morning, we are joined by Professor Matti Latva-Aho of the University of Oulu in Finland, who will be giving a presentation on the key drivers and research challenges for 6G.
Hello everybody, my name is Matti Latva-Aho and I'm Director for 6G Flagship Program run at the University of Oulu. I'm going to talk to you about some of the key drivers and challenges related to 6G. Related to our program, you have a chance to look for some of our recent materials at 6gchannel.com website, where we have published, for example, some months ago, 12 6G white papers, and very recently we have also released 6G Waves magazine of various articles and stories about us. We are also running currently a series of 6G webinars where all of these white papers are being discussed within an international arena. To start with 6G goals, we have to look at what are the key drivers for it. And we do believe strongly that United Nations Sustainability Development Goals is a nice, solid starting point for it. And related to sustainability, technology and technical solutions at various sides of and aspects of modern societies will play a key role in achieving those. And that's why when talking about 6G technologies, we are really inherently solving UN Sustainability Development Goals. And by following those and doing our job in developing new technologies and solutions of various sorts, I think we can all get to some new business opportunities for different verticals, which are critical for future societies. So actually this picture captures all the specific areas that we have touched upon in our recent 12 white papers. And I'm going to talk about some of those a little bit more specifically. We do believe that verticals are changing the value chains for the future, and we need something besides good old mobile network operators in order to move faster towards new vertical areas that are necessary for improving productivity of different parts of society. There will be new applications, new value chains will emerge around those, and it will be interesting to see how much world will be different already with 5G era, not to mention 6G era in 2030s. So verticals will be changing some of the current dominant value chain structures. Regulation policy is important enabler for making future innovations possible and allowing existence and birth, first of all, of new verticals and value chains. Just to mention one aspect of regulation policies is spectrum regulation, where we have to understand that lower part of the spectrum is heavily regulated already, and spectrum has been given mainly to mobile network operators, but we have a great chances at higher spectrum parts to have different novel regulation policies and to allow vertical-driven open ecosystems taking place more and more in the future. These white papers that I mentioned earlier, they have been developed in 2 consecutive 6G wireless summits, one taking place last year and one this year. And by the way, the next one will take place in conjunction with EU CNC conference in Porto, Portugal in June. And with a group of 250 experts coming from 30 countries and 100 organizations, we really developed those recent 12 white papers. The first white paper from 2019 was looking at high-level KPIs that we really would require besides these technical drivers and KPIs that have been already present with 4G and 5G systems. The new KPIs that we are talking about are related to ethics or UN SDG inspired KPIs, privacy, security, trust KPIs, transparency of system KPIs, and so forth and so forth. So these are really different from these previous ones, and they are bringing kind of a soft feeling, a soft nature for 6G development goals. This outcome of the second summit came up with these 12 white papers. I'm not going to go through them, all of them, because of lack of time. I'm just picking up some of those which might be of specific interest in the sequel. But all of these white papers can be downloaded from our website, 6gchannel.com. When we look at the importance of verticals, this table shows some typical and important vertical areas of various sorts, and related to each of these vertical areas, some assumptions, strong assumptions have been made related to the types of services that have been discussed in the white paper. And as we can see overall, the technical target values, is it data rate or latency or jitter or mobility level or capacity, they vary hugely from vertical to another. So it's a clear indication that if we have uniform design targets, irrespective of the types of verticals that we are thinking about for the future use, we are never going to optimize the solution for that particular vertical application. So we have to really take into account seriously the different types of requirements coming from different verticals. Broadband connectivity challenges are described on the left-hand side of this table, very typical, which are already a little bit present in 5G and more so in now in 6G era. And the technical solutions to meet these challenges are in the middle. And as we can see, just glancing through the different types of topics discussed here, we see that there's nothing drastically new under the sun. There is some sub-terahertz communications, intelligent reflective surfaces, visible light communications, massive MIMO is still there, machine learning, cell-free massive MIMO, and so forth and so forth. But what is really a big challenge and should be taken much more seriously in research is to look at implementational challenges and issues related to making these really happening. How do we make this really real life? And that's a greatest challenge of all. Of course, we have to still do high quality academic research in solving some of the fundamental issues related to each of these. There are a lot of opportunities related to localization and sensing related to future mobile systems. As we are moving to higher and higher frequencies, where the resolution for positioning is potentially much higher, and there are other also important features in the future systems, like bringing in the intelligence to be part of the networks, having these really dense antenna arrays, or having these smart meta surfaces reflecting our signals. So these are really changing the game in such a way that we can start to think about something quite unique and complicated. We are no longer talking about only radio positioning, but we are talking about 3D imaging with radio signals. We can start to think about developing joint communication and radar systems. But of course, there are these already mentioned implementation challenges related to high frequency signals, and those are really important to understand and tackle at early enough phase in order to come up with practical solutions for the future. Remote area connectivity is important to take into account in the beginning of 6G development era. Digital divide is increasing around the world, and we have seen that we have these days already a lot of societal challenges, and having a proper connectivity solutions is a key to try to overcome this digital divide. We need to have sufficient technical solutions to make it happen. We need also different regulative decisions, and we need different types of business models. Financing is a challenge. We need cooperation between different stakeholders in order to make it happen. Backhauling is quite often really the biggest challenge of all, and we may have places where we don't have any backhaul. We just have a local isolated private network, so to say, but the local community can have really great digital services being run at the local community. We have to understand that we are not necessarily always talking about the ultimate mobile broadband services in these remote areas, but we need a sufficient level for service quality at affordable cost. So that is really what we are looking at. Thank you for your time and patience.
That concludes our morning session for today. We'll be back after the break with our afternoon programme, which will lead into our live Q&A panel. And if you haven't already done so, please submit your questions now.